Okay, so logs, the whole point of logs is really to solve for an x that is in the exponent. Okay, so if I say like, all right, so 3 to the power of x is equal to 10, how would you figure out what x would be? No, that wouldn't. 10, 10 log, no. 10, what I would do, all right, well, I'm going to show you two ways. First way is what I kind of think of it as like throwing darts. So if you think of like, I don't know, I'm pretty sure I've seen this like in a million cartoons where there's like a bar scene and they throw like the daggers at a what's it called, a bullseye, and then the dagger goes like, and then like you could think of it as another dagger over here. Just kidding, not there. Another dagger right. Move this over to the side right here. Another dagger over here, and they throw it like this, and it still makes that same sound. So you can throw instead of daggers, because this is math, we're gonna throw logs. All right, so you threw two hands like this. Picture two hands and going. You with me? Like that. So yes, if you want to put logs into your equation, you got two hands, boom, throwing your logs down. They make that noise. Boom. You got log right there. You got log right there. Okay. But there's a little log rule. I think it's called the power rule, I think, where if you have this, no, but there's a calc power rule. That's something else. Okay, so if you have an x right there and you have a log, that x, or like anything, something in the power, like a power right there, that power can go bam right there. It can go right there. I've had long debates about this with students about whether it's that x went to the front or the back. I call it the front. Lots of people call it the back, just depending on how you see the situation. so, so, all right. So then you also just know that log 3, well, there's log and this number 3, they're stuck together. You can't just have the word log by itself. So if you have log 3 like equals, let's say equals 10, you cannot go like divided by log. That doesn't make any sense. They're stuck together. It's like sine of 30 degrees. You can't divide by the word sine. Sine without a degree is meaningless. It's like the word the. It doesn't have meaning. And so if you want to divide, there's times right here. You divide by log 3. Bam. Divide by log 3. Log, that's right. So logs allow you to isolate exponents. Isolate exponents. So we take out our handy dandy calculators and we go log 10. So log 10 and hit enter so we don't have to like do a bunch of parentheses stuff, and then divided by log 3, and you don't have to close it, and you find that it's 2.095. Do you have that in your calculator, that long number? All right, hold on one second. I want to put it down right here. Oh, yeah, that's what I was gonna say. Like now do 3 to the power of that. Well, what do you know? 3 to the power of that business right there, and you get basically 10. So x is 2. Well, the calculator is limited because it's stupid, but it rounded it off. 2.0959. So x is 2.0959. You got that? Okay, so that's the power rule. Let's talk about some other things. So I guess I'll write power rule over here. All right, so we'll start from the beginning. So you have, let's say you have 3 to the power of 2 equals 9. Well, this 2 right here, guess what it's called? It's called an exponent. And that 3 million bucks, if you know what that's called. Please don't know it. Yes. Okay, and so then, and then over here, this one is called the answer. The answer. All right, so you have an exponent, you have a base, you have an answer. Okay, you can rewrite this entire thing in log language, which, I might forget, but there's one thing I know how to do. No, but I do know that when you say logs, like if you go like log and then this thingy down here, you put something down here. Well, if there's a 10 there, it would be log base 10, right? Or if there's like a 3 there, it'd be log base 3. Well, I want to have a 3 there because that's the base. Because this is the base. So this is the base. You with me? Okay. So it is, well, hold on a second. Hold on. So then I also know that, um, yeah, that the power goes here. And I also know that the answer goes here. So this right here is your exponent, and this right here is your answer. And I have a student that we kind of see this the same way, I guess. I think his is a little more animated, and he says that he refers to it as the dun, 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 rule. And I'm like, what? What? It's like he's like, allow me to explain. It's like I think of it as this 3 goes here, and like in Mario, when Mario like bumps like the mushrooms or something like that, it kind of like bumps up and bumps up and down and goes boop boop boop. So he kind of does it. He does that little like animated thing. So he knows that it's like if he wants to put it back to the other way, it's like boop 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 boop. And it goes boop boop boop. So he's like it's a bump 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 rule. And we have so that's it. So this means the same exact thing, right? So if we get our calculators out, calculator, go over here, and we go log base 3, which by the way, new calculators, you can actually like do log base 3. Didn't used to back in the day, but right there, bam, log base 3, and then 9 is 2. All right, so that's that. Those are our log basics right there. There's a couple more things. So that's just like understanding like how logs work. Oh, before I forget, this is another thing that used to kind of annoy me, which was ln, natural log. So let's do like the ln. Let's do ln of like 5. If you really want to annoy a teacher, just call it ln. Okay, so ln 5. So ln 5. If I see these guys right here, I don't use them at all because I find them to be very confusing and disturbing. So I rewrite them into what they really are. So all ln is log base e. So no, e is magic number e. It's like 2 point something. If you punch if you do e in your calculator, and if you want to look it up on Wikipedia how to get e, it's there. But like it's e is yeah, it's right here, 2.718. It's second above the division symbol. All right, but hold on one second. So so ln5, if I wanted to just rewrite that, make life easier, I would just write it as log base e 5. That's so now if you have, let's back up for a second and let's talk about log base 10 hold on, yeah, log base 10 10. Do you know what this answer would be? Like, what would go here? Like, what? 1. Why 1? Yeah, because 10 to the power of 1 is 10. Okay. So then we see things like this, like log e. Can you explain why log e is 1? Why? Well, because ln e, well, first of all, we have two types of e's going on here. We got red e and blue e. You have log base e, which is implied in here. Then you have red e, which is here. Do you see that? So yeah, exactly. So e ln of 1, let's think about this for a second. So ln of 1 totally confuses me. Rewriting it. Log base e, what? Yeah, it's 0. E to the power of 0 is 1. That's right. That's right. Anything to the power of 0 is 1. So ln1, which really I don't like that, is I rewrite it like this. And then I can easily see with my Mario action that e to the 0 is 1. So it has to be 0. You get that? Oh, anything to the 0 is 1. But you have an e there. Okay. So, got that taken care of. A couple more things. All right, so let's say we have, there's what's called the, what's it called? It's called the, I think it's called the product rule, where you have log. Oh, by the way, if you have log and there's nothing down here, it's implied log base 10. It's like the square root, right? There's an invisible 2 right there. Well, with logs, if you don't have anything down there, there's an invisible 10 right there. Because the guys with beards and sandals made up that rule. So yeah, so your button right here, um, if you use this button right here, there's an implied base 10. Yeah, and just like if you use this button right there, there's an implied 2 up there for square root, not cube root. Okay, so so if you have log, like, oh, I'll use the same like letters they use in the book, mn. So, oh, and by the way, this little area right here, we're gonna use some math terms. This little area is called the argument. It's called the argument. So, if I go like this, sine of 30 degrees right here, guess what's in the argument? Nope, 30. 30 degrees in the argument. When I'm dealing with this log right there, guess what's in the argument? mn. Okay, so the log rule is when you multiply it in here, it means you can rewrite it by separating the two of them with addition. So that means that this right here is the same exact thing as log. Don't forget there's invisible bases right there. So m plus, yeah, log, log n. With me? All right. Next thing um, is it also the reverse process, right? So if you have like log a plus I don't know, what's about to spell with that one. Log B. Well, that's the same thing as log what? A times B. All right. Um, Subtraction rule, which is when you're dealing with division. So if you have log, no problem. I haven't that movie, by the way. I hadn't seen it since like it came out. She's the man, yeah. And we were trying to think of a good movie to watch with the kids, and my wife came up with that idea. And I was like, is that like kid appropriate? Can I see that? And then I like looked it up online, and I was like, yeah, it's actually not that bad. Yeah, yeah, that was pretty funny. Um, okay, so you have log m over n. Well, that's the same exact thing as. What do you think it is? Log m minus log n. All right, so there's that. Um, there are, let's see, a couple of other things that I'm forgetting. Hold on a second. Okay, so the goal for this problem, the goal to do this problem is to solve for x, right? Because it says solve for x. Now, um, if this problem said like log log 5 um, x minus 8 equals log 5 um, actually hold on, I was going to tell you something but I want to confuse you. So you need to basically get the logs together on one side because that way you'll see like maybe like a subtraction between them. You see, so if you go minus log 5 x minus 4 and then minus log 5 x minus 4. So I'm moving this to the other side. So then you end up with, are you with me or no? Wait, it's all kind of squished in there. No, the whole thing's going for the ride. So minus log 5. The entire thing. Not yet. It will in a second. Well, no, actually it won't. Oh yeah, it will. Yeah. So that's gone, right? And then you end up with log 5 x minus 8 um, minus log 5 x minus 4. And then you can combine them. How can you combine? Good. So log 5 x minus 8 over x minus 4 equals what? All right, and then what's the bump rule? So we can rewrite this whole thing and get rid of logs completely. How would you do that? 5 to the what? Equals what? No. Well, yeah, but equals what? Okay, so look. No, it is, but watch. So you have, no. So back to over here. Where's that rule? Did I erase it? Where did it go? Here, kind of. So when we were doing this one here, and you move this over here, 10 to the power 1 equals 10. The log's gone. It's You just translate it to a different language. You went from log language to exponent language. Do you see? So no, so it's over here. It would be 5 to the 1 equals x minus 8 over x minus 4. You see? And this is gone, and so it's like this goes over here, boop, 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 and then this is gone. See? Then you solve that. So I have a cross multiply. So I'll go like that and cross multiply. You can only cross multiply when you have a ratio equals a ratio. When you have like a fraction equals a fraction, not when you have a fraction equals a fraction plus a fraction. You can never do that. It has to be one fraction equals one fraction. And so that's what we have. All right, so we multiply both sides. And what do we get? Wait, multiply. So we're going, like, basically you can do that times that, right? X minus 8 equals what? Good, 5x minus 20, so you distribute. All right, so then go minus x, bam, negative 8 equals 4x minus 20. All right, plus 20, plus 20. And the thing about logs also is there's kind of more than one way to solve them. 28. I could have done this one different. I could have solved it a different way. Oh yeah, I subtracted it wrong. It should be 12. I was checking your math. That was your mom was like, make sure you check his arithmetic. And I was like, oh, I know exactly what to do. 4, and then 4, and then x equals 3. Bam. Um, by the way, technically, log problems are checkable because you could just go like this, and you could plug 3 back in. And you're not allowed to, you cannot take log of, the argument can never be negative, by the way. Yeah. So like so if I go like log like -2, you got a problem. So all right, so we're gonna do log base 5, so not that one. So math, go down here, or log base 5, and then we can. What did you say it was? Did you say 3? What did we say it was? Oh, that's awkward. Oh yeah, right. But I think hold on. So look at here. Um, they plugged it in, and actually there's no solution. So if no solution is an option on the test and multiple choice, you definitely want to investigate that. Make sure it doesn't come up as no solution. Um, okay, hold on a second. Okay. So here, oh yeah. So there's 2 ways to solve this problem. The first way is to just rewrite it using your knowledge of logs and the rule. Yeah, that's perfect. The next way to do it is to throw your darts and go log 7 6y equals log equals 9. You can't throw 3 darts at once though. It's only 2. One there, one there. Either way will get you the answer. So um, I'm used to this one because I just think the darts thing is cool. But most people do this. So um, your calculator is very good at this because of the whole base function. You see, so you'll get instantly an answer right here. Like right, so you just go here, and you go math, go backwards to learn that's close. You're going the other way, and go, and then we have log base 7, 9, enter. So we have that right there, right? And then what's the next step? There's only one more step. No? So 1.19, no, 1.12, all of this is 1.12 equals 6y. See? All that 1.12 equals 6y. One more thing to do. Yeah, that's what you do. Divide both sides by, yeah, divide by 6, divide by 6. Y equals 1.12 over 6. And then just punch that out in the calculator. So just like decimal. I I doubt mixed number. 1.1.12. The only time you use mixed numbers is up to 5th grade in real life. 1.12 divided by 6. Yep, 0.1866. 0.1866. And then this one over here, using the darts, you get to use your power rule. This goes over here, bam, and then divide by log 7. It's just getting sloppier and sloppier. Log 7, and then divide by log 7. My rule, by the way, the dart rule, takes it to log 10. 6y equals log 9, because I can throw log base whatever I want, and I'm throwing log base 10s. So I go over here, and what's that? Uh-huh. You can just use this button. Log 9, enter, divided by log 7. Enter, divided by 6. And there's your 0.18. So y is equal to 0.18. Pause.